So now we will look into how to determine intersection of two lines. So in a space, when two lines, there is a possibility that two lines are parallel. If they are parallel, means they do not intersect. Or second scenario would be these two lines intersect at each other, and if two lines intersect, if the resultant will be a point in terms of x, y, and z. Or the third scenario will be if the two lines are skewed or not parallel, but they will never intersect. Okay. Next, if two lines intersect and you're required to find a point where these two lines intersect, there is a strategy to actually determine the point of intersection of these two lines in a 3D space. So these are the steps written down. So the first step is express the equation of the lines in parametric form. So we have looked at what are parametric form equation, meaning equations in terms of the parameter t. So since there are two lines, so you can express the equation in terms of parameters t1 and t2 respectively. The step 2 will be equate the corresponding expression for x, y, z, meaning x of t1 in terms of t1 and x in terms of t2. You can equate them to produce three equations in terms of two different unknowns. Okay, and then the third step will be you can use two of the equations to find the value of t1 and t2 respectively. And then the fourth step will be you need to substitute these values you found of t1 and t2 into a third equation, and if they satisfy the point or the third equation, that means the lines intersect and actually produce a point. So if the third value, if the third equation is not satisfied with the value of t1 and t2, so the conclusion will be the lines will not intersect. So next we will look at some examples which actually applies this fourth step to determine whether two lines intersect or not, and if they intersect, what and how to determine the intersection point. For example, if you need to show that these two lines as stated here, the first line is x minus 5 over 1, negative y over 2, negative y plus 2 in bracket over 1, and z over 1. Right, and the second equation is as stated over here. Okay, so you need to show whether these two lines intersect, and for the second part of the question, you need to find what is the point of intersection. So in this case, we will follow the 4 steps that I explained in my previous slide, right? So the first step here would be you need to introduce parameter t1 and t2 to these equations of lines respectively. So we're going to equate the first equation to t1 and the second equation to t2. So in this case, when we equate our first equation to t1, so x minus 5 will equal to t1. Okay, so x will be t1 plus 5 if we just move the 5 over to the right hand side. Okay, and then you repeat the same procedure for y and also z respectively, equate it to t1. So you will get x equals to t1 plus 5, y equals to negative t minus 2, and z equals to t1 for the first equation of line, which we equate to t1. Then you move on to the second equation, and you need to second equation you need to equate it in terms of parameter. So we use parameter t2. So for example, if it's x minus 12 equate over 5 equals to t2, so x will simply be 5t2 plus 12. It's just a rearrangement using basic algebra. So you will get x, y, and z when you equate it to t2 in terms of as it's shown here, right? So once you get your x, y, z from t1 and x, y, z in terms of t2, right? Your next step would be you simply need to equate the x with x and the y with y, because you need to find the value of t1 and t2. So for the next step, you need to equate the x with the x. So for example, you're equating x to x because x and x should have the same value. If the two lines intersect, the value of x and x has to be the same for both equations, and also followed up by y and z. So if you want to equate our x in this case, so t1 plus 5 equals to 5t2 plus 12. So both the x are equal. So when you rearrange, you should get t1 in terms of t2. Alright, so in this case, t1 would be, by rearranging this equation, you will get t1 equals to 5t2. 12 minus 5 equals to 7. So you will get t1 in terms of t2. And then you respectively equate the y with the y. And you will reduce your t1 to 2t2 plus 1. And equate your z and z from both equations. And you will get t1 equals to 42 plus 5. So you have completed your step 2, which is you need to equate t1, or you need to get t1 in terms of t2, which is a part of process of solving the equation. So now you have got enough equation to solve your t1 and t2. So t1 and t2 are just only two unknowns. So you can use the first two equations to solve and get values of t1 and t2. So in order to solve t1 and t2, we use the first two equation, as in equation 1 minus equation 2. Okay, so 1 minus 2, t1 minus t1 is gone. t1 minus t1 is a 0. Okay, 5t2 minus 2t2 is 3t2. 7 minus 1 is 6. Okay, so equation 1 minus equation 2, you manage to solve your t2 is negative 2, and then you can use either equation 1 or 2 to solve your t1. So by substituting it into, say, the first equation, we have got our t1 as negative 3. So step 3, we have solved the value of t1 and t2. Now next, we need to ensure that and prove that the two lines intersect. So therefore, we need to confirm it by using the z value. So the way to confirm is substitute the respective value of t1 and t2, which you have obtained from the first two equations, into the third equation to test whether the lines intersect or not. So what you can do is you can substitute t1 as negative 2 into your third equation of z, and also t2 as t1 and t2 respectively into the equation of the third equation. Yeah. So when you substitute, you will actually get z as negative 3. When you substitute t1 as negative 3, you will get z as negative 3. And when you substitute t2 as negative 2, you will get negative 8 plus 5, which is also negative 3. So now the z values are the same. This is a proof that these two lines actually intersect, and they actually produce a point of intersection, which is simply 2, 1, negative 3. So recap back, when you are required to answer a point of intersection, your final answer must be in terms of coordinate, in terms of x, y, and z. Next, we will look at how to determine angle between two lines that intersect. So if two lines intersect, the resultant is a point, right, which in terms of x, y, z, and obviously there is an angle between two lines. So for example, if you have two lines that intersect this way, right, definitely there is an angle involved here. So that's what we are looking for in this question. Okay, so in this case, your first step would be writing the equations of lines that you have in terms of the symmetric or the standard form. Okay, that is how as the first equation is, so that you are able to identify the vector. Right, that's the main reason of writing it into a symmetric form. So the second equation here, you are given in terms of parametric. All right, so you need to convert these equations in terms of symmetric form. So how to do that? You can just convert your x in, you can just make the t as a subject of the equation for each x, y, and z respectively. So what you do here is x equals to negative t plus 3. So you can convert it simply by making t as your subject of equation. So it will be x minus 3 over negative 1. Right, that's how you got this symmetric form. And you convert the y and z respectively by making t as the subject of equation. Right, so that's your first step. So once you've already got all your equations in terms of symmetric form, your next step will be identify the vectors of the symmetric form. Right, so you have got these vectors because these are the denominators actually represent the normal vector to the particular line. All right, so next, once you've got the vectors, so you're given two vectors. These two vectors came from, the green vectors came from the values of denominator of the first line, and the red one came from the denominators of the second equation. So what is the purpose of finding these vectors? It is simply because whenever you need to find angle, you always apply a formula which is this. Cos theta equals to A dot B, which is scalar product of A dot B, and A and B are vectors respectively. And modulus A, modulus B are basically magnitude of vectors A and B individually. And this theta here represent the angle. So we need to find the value which is A dot product B over modulus A modulus B, and then we shift cos the values we found from A dot B over modulus A modulus B, and we will actually arrive to the theta value. And bear in mind, it has to be acute angle. So acute angles are simply angles which are less than 90 degrees. So for example, we calculate cos theta. So we need to find the dot product. So dot product is simply obtained by multiplying x with x. So 1 times negative 1 is negative 1 plus negative 2 times 1. So plus negative 2. And the y and y will result in is a 0. So plus 0 over 1 square. So it's 1 plus negative 2 square plus negative 1 square is basically 6. 1 plus 4 plus 1. And the second one is negative 1 square plus 1 square is 2 plus 0 square, so it's 2. Right, so it's modular surd of 6 multiplied by surd of 2. It's also combined and you get surd 12. All right, so you add them up and you simplify it. You will actually arrive to a value. It's not necessary to leave the answer in a surd form. You can always calculate it in a as long as you calculate the value of cos theta is fine. It can be in decimal form, it can be in surd form, it can be exact value, non-exact value is fine. And then finally, what you need to do, you need to shift cos this value so that you can actually get your theta. So in this case now, your theta is 150, right? So obviously, because it's clearly stated here is acute angle, so you need to find the corresponding angle to 150. So 180 minus 150, you will actually get the acute angle that is related and which is actually between these two lines.